You're on 94.9. It is 4:15 and it's that time of day for Creation Ministries International. And this afternoon we have Dr. John in the studio. Good afternoon, Dr. John.
Good afternoon, Mick.
It's great to have you here again. And of course, Creation Ministries International have a website, creation.com. If you do have any questions, you can go to the website anytime to get your questions answered. But more importantly, and more to the point, right now, we've got a little screen in front of me that has all our text messages come spinning up. And that's from people who have questions for Dr. John or any of our Creation Ministries speakers. We'd love you to send us your questions. If you have any questions, just text them to us. SMS 0401 949 949. That's 0401 949 949. Now, we know it works because we've had a few questions just last week and this week, Dr. John.
Yeah, Mick, it's great that we've got that phone working properly again because there was a time when we didn't seem to be getting too many questions. But now it's on stream again. So everybody, whatever questions you've got, text them into that 0401 949 949.
That's the one, absolutely. Now, Dr. John, the last question that we've got actually relates to what we were talking about last week. And it was, hi, Dr. John. Last week you spoke of nucleotides. A couple of years back, before COVID, at a church presentation, I heard you speak about cystic fibrosis and the tiny fault in the DNA. Could you reiterate that small problem with such impactful struggles within the body in understandable DNA terms, please? Thank you.
Understandable DNA terms. Yeah, hopefully I can. And look, it's great actually that particular question came in because it really fits in with what we were talking about last week and what I wanted to continue on with this week. Because last week we were talking about the differences between birds and reptiles.
Yes.
And the reason we were doing that is because modern scientific thinking tries to tell us that the dinosaur didn't really die out.
Yeah.
You know, don't worry about those asteroid impacts or whatever. Might have killed a few, but it didn't kill them all because they simply evolved into birds. Well, this is what modern scientific thinking says. Now, I mentioned that evolution, like that evolving into birds, supposedly occurs by mutations or changes in our DNA. And those changes can only occur really one nucleotide at a time. And I think last week we mentioned we've got 3 billion of them. And you can only change one at a time. And by definition, evolution doesn't have any idea of the direction in which it's going, just haphazard, And supposedly you get a build-up of each of these individual little nucleotide changes, supposedly good ones, making things better, and it just goes on and on and on and on and on. But you see, the differences between birds and reptiles are so vast that you'd have to have hundreds of millions of these little individual changes, all changes for the better.
So what you're saying is these are like 100 million little missing links.
Changes. Yeah, I guess you would call them missing links.
Because we haven't found them. We haven't found the ones in between that have those half changes on them.
That's exactly right, and we haven't because you often find now if your kids or your grandkids are getting dinosaur picture books, they will probably see that the artists are sometimes drawing feathered dinosaurs because they're assuming that dinosaurs evolved into birds.
Yep.
Now, there haven't been any feathered dinosaur fossils, right? So what you see in the picture books really is the imagination of the artist just trying to draw what the scientists believe, because there's absolutely no evidence for that.
Yeah.
And you get the picture. People think of white-coated scientists in their laboratories working away there, and following new leads and following new leads, whatever direction they're going in, you know, because they're supposedly seekers after truth. Well, I've got bad news for you. They're not seekers after truth, because if the direction in which it's going doesn't agree with conventional thinking, then they're not game to follow that direction, because they're likely to be ostracised or lose their job or whatever. And I mean, we've seen plenty of that recently with COVID and all these things, you know. Whatever direction doesn't accord with mainstream belief, then you better not mention it, because you're going to lose your job. So really, scientists, they're not really going to follow whatever direction it's leading. For example, I mean, we've mentioned before the global flood. Now, there's massive evidence for a global flood and all the geological structures in the earth. And not only that, there's other ancient literature that talks about a global flood besides what the Bible says. But no, they're not going to go there. They don't believe there was a global flood. But, you know, they think there might have been a global flood on Mars.
Yes.
And never been there, but what the little rover sends back, we think there might have been a global flood there, but not here on Earth. Oh no. I mean, it really is just amazing. But for me, and we'll get back to the nucleotides question that our questioner has typed in. For me, the absolute clincher that evolution is impossible is in DNA, because if I can explain DNA, it's actually fairly simple, but it's complex too. And without the use of diagrams, it's pretty difficult to explain over the radio. But you can consider the DNA molecule a bit like a twisted ladder or a twisted zipper. Now, you think of a ladder. A ladder has got sides, and those sides in DNA are made of a sugar phosphate compound. And the sugar is deoxyribose, which is where it gets its name from. But the rungs of the ladder, on each rung is made up of two of these nucleotides. If you then think of the other analogy of a zipper, you got the two bits of the zipper fitting in together. So each rung of this twisted ladder is made up of two nucleotides, and there are four of them. And for simplicity, we give them their first letter. There's adenine, thymine, cytosine, and
and number
guanine, A, T, G, and C. And A always links with T, like in the zipper analogy, and C always links with G. But and there are about 3 billion of them in our DNA program. So the order that they're in is the program. Now, if you think of comparing that with what everybody sees as on their computer screens as a computer program, like a URL, you know, you see all of these symbols of the keyboard, and it looks very complicated. It looks to be lots of symbols, but as we know, they're really only two. You know, every symbol is made up of some combination of two, on or off.
There's zeros and ones.
Zeros and ones, you know. So what looks very complicated is really only two, whereas DNA has got four. So, I mean, it's already twice as complex as your computer programs. But the interesting thing, and this is where we get to the question that our friend sent in. One of the features of DNA, of course, is that it can reproduce itself. And in cells that multiply, like cells that divide, things like the cells on your tongue and all this sort of stuff, they have to reproduce themselves. Mm-hmm. And sometimes in that reproduction, there's a copying mistake, right? And that's really what a mutation is. Mutation just means change. Mm-hmm. And sometimes there's a copying mistake. Mm-hmm. And the cell is actually able to correct itself. It gets rid of the copying mistakes and so on. But sometimes that doesn't work perfectly either, and the proofreading doesn't work properly. And so that copying mistake gets continued. Mm-hmm. So that's what we call a mutation. But almost invariably, they're harmful. They're going the wrong direction. I mean, if you think of randomly changing some of those symbols in a URL, it doesn't usually run that well. In fact, usually it doesn't run at all. Yep. Right? Now, biological systems are a bit more forgiving. They'll usually run, but they won't run quite as well. Yeah. And so when you look at the mutations, they're going in the wrong direction. The train's going the wrong way. It's never going to get to the evolutionary destination. And bear in mind, you've got to have hundreds of thousands or even millions of these favourable mutations when scientists can't point to any. Right, you've got to have hundreds of thousands or millions of them to get from scales to feathers, or four legs to wings, or whatever. Yeah. But they'll still depict the dinosaurs with these, four legs turning into wings and feathers on them. But anyway, we're going to get back when we come back to our question about the DNA change that causes the disease cystic fibrosis. And you'll see that you really can't afford to have very, very big changes, because they're going the wrong way, and they usually do cause problems.
All right, you're on 94.9. It is 27 minutes past 4. We're with Dr. John from Creation Ministries International. If you have any questions, please send them through to our text line, 0401 949 949. You're on 94.9. It is 23 minutes to 5, and we're with Dr. John from Creation Ministries International. He's been talking to us today about, DNA and about mutations, how mutations always seem to go one way. Mutations are a bit like, you get a hammer, you throw it at something and it breaks, and it's like saying, hey, look at the big chunk of metal over there, I'm going to break it and it'll turn into a car. Tends not to work that way.
No, it doesn't. And we compare DNA to computer programs because DNA is a program. Mm-hmm. And with programs that are properly running, if you start randomly making changes in the program, it usually corrupts them. They don't run quite as well. Yep. In fact, computer programs don't run at all. But with biological programs like DNA, it's a bit more forgiving, and they will continue to run. But as you would expect, they don't run quite so well. Yeah. And mutations or changes in those DNA letters are invariably in the wrong direction. And yet for evolution to occur, there'd have to be hundreds of thousands of them, all in sequence and all favourable. Well, that just doesn't happen, which is why evolution is actually impossible. Yeah. And the question we got was about cystic fibrosis and the change that has occurred to cause that very, very serious illness. Yep. And it's not a big change, because cystic fibrosis is associated with a defective protein. Mm-hmm. Now, the code for proteins is on the DNA. And we make thousands of different proteins. Proteins are things like collagen or muscle or hemoglobin or insulin or estrogen or testosterone, things like that. Yep. And if we take, for example, a very, very small protein, some of them are huge, but insulin's a small one. Mm-hmm. Insulin has about 80 amino acids. Now, each amino acid is coded for by 3 of these nucleotides. Mm-hmm. And they form three-letter words like CGA or CTA or ATG or whatever. And so insulin is a protein made up of 80 three-letter words. And each of those three-letter words has three nucleotide bases.
Yep.
So we're talking about 240 letters divided up into three-letter words to make insulin. Now, when you consider something like the protein that's associated with cystic fibrosis, it's got about 1,500 words, not 80 like insulin, which is small. 1,500 isn't terribly large anyway as far as proteins are concerned.
Yep.
But it's about 1,500. And at one spot in the middle of the program, there's one three-letter word, one nucleotide, one amino acid missing. So it's a three-letter word that is missing. Now, if you think about what sort of a mistake that is, if you gave a typist a 4-page letter to type, and the typist omitted one three-letter word like an and or a but, you wouldn't think that was a huge mistake.
No.
But in this case, it is a huge mistake and it causes a defective protein. So you don't need big mistakes to corrupt things. And this is why, of course, with a lot of the genetic diseases, you don't want to have the same mistake in both mother and father. And you're more likely to have that if they're closely related. So that's why you don't like close relatives marrying, for example.
Yep.
But anyway, that's the way things are with DNA. And this is why I think that is DNA is the clincher. You cannot possibly have evolution because you just don't get those favourable changes which it depends on.
Yeah.
So as far as I'm concerned, we have to go to God as creator because the program that he has created with DNA is vastly more sophisticated and complicated than the greatest computer program that man has ever devised.
Yeah.
You walk into a robotised car factory and you know that there's this huge complicated program running that whole thing. Well, it doesn't even compare with DNA. And it can't reproduce itself and it can't correct itself and things like that. So, DNA to me is the clincher. Evolution is impossible.
Yeah. I mean, it makes sense, everything you say. It's a code, and any code we know, when you break the code, when you take something out of the code, it's no longer that code. It doesn't work. It doesn't do what it was meant to do. Computer programs, we see it all the time when things sort of go a bit weird. Well, our computer just shuts off. It goes to the blue screen of death. That's because of some very simple code going wrong. Yet these people believe that something's just gone wrong, and all of a sudden we've made this extraordinary life or these extraordinary changes. But it's never been proven in science. It's just someone's weird theory.
The examples of favourable mutations or changes are simply not there.
Yeah. Okay, now we had another question, Dr. John. Should I ask that now?
Oh, yeah. I think we've probably got time to quickly do another one.
All right. Well, hi, Dr. John. Is it biblically correct to call humans Homo sapiens?
Yeah, look, that is a great question. And the answer, of course, is that it is not biblically correct because as soon as you use a term like that, you are assuming that evolution is true. And I'll explain why. You think of those two words, homo, which is Latin for man, and sapiens, which is intelligent, right? Yep. So we're talking about intelligent man. So as soon as you use that term, you're assuming that there is perhaps a non-intelligent or not as intelligent man who came before that intelligent man.
And of course, there are other words put together that mean that.
Well, that's right. And you think of another term that you might see in anthropology, Homo erectus.
Yep.
That is, man who stands upright.
Yep.
Now, that's assuming that back in the dim, distant past, there might have been a man who didn't stand upright.
Yep.
You know, who could perhaps stand upright but didn't walk upright. You know, walked along a bit of a knuckle walk.
Yes.
Yeah. Right. So all of these terms assume that evolution has occurred. So they're not biblically correct terms.
Wow.
Now, you think of and the other ones that you see around, which sort of purport to show where this early man or whatever came from, Homo neanderthalensis or Homo heidelbergensis or floriensis or whatever. They're assuming that these supposed early people were on the progress to modern man. You know, Homo sapiens.
Mm-hmm.
Okay, so with all of these terms, it's assuming evolution. Now, the Bible doesn't allow for any of that. You know, as far as the Bible is concerned, God created man only about 6,000 years ago, and he created him in the form that he is now. Mm. He hasn't progressed from one to through non-intelligent man to intelligent man, or to knuckle-walking man to walking and running man, or anything like that. So all of those terms assume evolution to have occurred.
Yeah, yeah. I mean, it only makes sense. We sort of, you look at monkeys, we've found plenty of skeletons. We've got plenty of skeletons of man. You know, there's this missing link in the middle, but there's actually a lot of links in there from what you're saying. It's not just one link. There's a lot of things in there that had to change. But we've found no evidence of any of them. It's just gone whack one to the other. And what you're saying, you know, making all of those changes from one to the other is it's impossible.
Well, if you walk down the street, Mick, in the city of Sydney, you'll see people of all different shapes and sizes walking around, you know, and you can be pretty certain that if you got all of their skeletons, then there'd be considerable differences between all of them, but they're all people.
Yeah, look, I know in our family, and I know in families of friends of mine, you know, you'll see a certain family and they're all tall. You know, tall mum, tall dad, all the kids are really tall, and they've even had kids that are really tall as well. And you think, okay, well, if that family, you know, potentially got moved into an area where there was no other people and they just kept going as a family, they'd probably all be tall for a while. And we've found, and I know there's been, you know, paleontologists and whatever the guys are that dig up bones, they've found skeletons of people that all looked similar. But you can't say they're not the same people. It's just like a family of people that slightly changed.
That's right. And there are some skeletons of people who are small. I mean, we still have living people who are small, pygmy-type tribes and so on, because they've been isolated and they've just bred with one another, and they're all small. And yet you find others who are basically almost giants.
Yep.
You know, so there's a huge difference in the range of modern humans anyway. And so, yeah, I would say to our questioner, don't use the term Homo sapiens because it does imply evolution.
Yeah, yeah. What about the term Neanderthal? I mean, we use it a lot as though it's a completely different race and type of being. You know, it's not the same as us. It's a previous type of us.
Yeah. Well, look, we know from DNA examinations that we all have some Neanderthal DNA, and Neanderthal just means that's where these skeletons were discovered, in the Neander Valley in Germany, because Neander is a river and Thal means valley in German. So that's
they always draw them to look the same, though.
I know, and they always try to make them that little bit backwards so that they might be on the road to modern man. But we know that the Neanderthal people, they drew pictures, they had musical instruments, they made tools. In every sense, they lived exactly the same way as we did, and they interbred. Well, I mean, it all goes back to the Tower of Babel, when God separated people into tribes by language and paternity. So because it was paternity, then they were tribes mostly descended from one person or one patriarch, if you like. So they were all different, even though they were related at that time. But by the 5 generations after the flood, they were, cousins 5 times removed or whatever. So there was quite a difference.
But just like any family,
of course,
that we've seen, the family changes. They're just it's almost a family trait. They're slight differences in looks.
That's right, and the same goes for skin colour. The Neanderthals, who were probably very light-skinned people because they tended to live in the colder climates, whereas some of the others that migrated to the equatorial regions were probably darker skinned, and there's reasons for that too.
Yeah, absolutely. Dr. John, thank you. Another awesome week, and you're not with us next week.
No, I won't be now for a few weeks. I'm not sure who's on next week, but in a couple of weeks' time, you're going to have Dr. Mark Harwood 2 weeks in a row, because I substituted for him a few weeks back, and he wants to do the 2 weeks in a row. So that'll be great for our listeners to look forward to.
Excellent.
But that won't be next week.
No, Dr. Ronella next week.
Right.
Taz Walker the week after. Then it looks like 2 weeks of Dr. Mark Harwood.
Look, the listeners, please tune in to hear these guys, because they are excellent.
Excellent. Awesome. Thank you, Dr. John. It is 9 minutes to 5. You're on 94.9 this afternoon. Hey, if you have any questions for any of those CMI guys, please send them through to our text line. That is 0401 949 949.